much, everyone. That V-bot will do exactly what we told it to.
Can we do on the table?
Oh yeah. Press the X to cancel it. Come here. Press the go button, or did it delete the code? Here, put it on the table here. And press go. Yep. So this is an example of a simple robot. Now notice, other than this button, this robot doesn't have any sensors. So it can only do simple things such as moving forwards, backwards, and repeating that task over and over again. This is where we go to robots such as dashboard.
Have you seen something like in your house? What is it?
Roomba.
Vacuum. So we already seen those in the live. We thought we never seen those.
Roomba is also correct. Roomba is the other word we use for vacuums.
Yeah.
So then you have the dashboard. Dashboard does the same thing in terms of moving around. Difference is it can move around in a variety of ways because it has the two motors there and something at the back there. I think it's a motor. And besides that, it also has little proximity sensors at the front. And this is useful. For example, if you're in a car and let's say this was an automatically driving car. If a car got close to another car, what do you want it to do? Stop, right? Because of that, that's what things such as proximity sensors are useful for. And also, ultrasonic sensors. Don't make any noise. Okay. So this is a dashboard. The useful thing about a dashboard is that it can also make its own sounds as well. And similar to cars and other vehicles, you also want them to make their own sounds, which is pretty cool. And I do want to talk more about it, but we're just going to keep running through things. So turn off dashboard. We're going to end this full live. And then after the dashboard, we have the CoDrones. So this is what I was talking about earlier. You can use CoDrones, which are pretty much normal drones. Difference between a CoDrone and, or let's say a robot drone and a normal drone is that a normal drone we have a controller for it, right? Meanwhile, a CoDrone, you can program it to do things on its own. All you have to do is run the program and it will lift itself from its own little helipad and then start doing whatever you told it to. You can tell it, hey, if you see this sort of color or this sort of brightness of light, react to it accordingly. Maybe send me a picture, that way I can see if there's a fire there. If there's a fire there, tell me your location. I'll send someone there to go and take care of the fire. This is a useful application of robots that we're still trying to take advantage of. I know, I think it was in Africa that they had medicine being sent over via, I think, airplanes, right?
They use it for the, what's the difference between, what is it, everybody know what is it?
It's a drone.
Okay. Can we call it the flying robot? No.
Sort of.
No. The reason is, it needs a human to drive it. You manually, remotely do it. But if I do the same thing with this one, I can put a code there, give a location and give a task, go and do this. Maybe drop a medicine in a remote village. This can do. I can ask it, go my farm, count all the cattle and send me a report if they are less than yesterday. So this can become flying robot when it becomes automatic. Make sense?
Yep.
And we need a lot of them. Australia is too big to look after.
Then we go into other things such as Arduinos. Arduinos are more of the advanced crop of robots where we'll be learning about things using electrical circuits. And if you're trying to work with electrical circuits, this is very useful. Besides that, what we're going to be using today is the Mindstorms EV3. So the EV3s have, I know it says sensor here, that was a technical typo. EV3s have your brick. Your brick acts as the brain of your computer. And you have different motors, not sensors, ignore that. So large motors are great for when you're trying to move around and do very heavy lifting. Medium motors are great for trying to do simple movements such as the movement of an arm. Then you have ultrasonic sensors. Now, what is an ultrasonic sensor? Think of it like a distance sensor. I will explain later on, maybe at the end of the workshop, how it actually works, the science of it. But all you need to know is that it gives us the distance. Color sensor tells us color. Gyro sensor pretty much tells us how much our robot turns. So if you do a 90-degree turn, it'll be like, hey, you've done, let's say, 89 degrees. And then a touch sensor, you pretty much touch it, and then through this wire it sends signal to the robot saying, hey, I've been touched, what do I do? And the robot's like, oh, touch means stop, okay, we're gonna stop. So these are different sensors. There are many more other sensors as well. You also have temperature sensors, you have a bunch of other sensors as well, and I'm still trying to learn more about them. And that's the EV3. How do we program robots? depending on the robot, you might be able to program it wirelessly. EV3s in this case, we're going to, I made a mistake there. EV3s in this case, we're going to be connecting them via a USB cable, and we're going to be downloading the code onto here, and then we press this button to start the code, okay? We'll go through more of that later, but whenever you're programming a robot, once you download and run the code to test it, you go through a step, and this isn't just for programming, this is for all coding. You go through a step called debugging. Debugging is pretty much, you tell the robot, hey, move 10 centimeters forward. And then the robot's gonna be like, okay, moves 50 centimeters forward. And then you go to the robot like, hey, why didn't you move the 10 centimeters? The robot's gonna be like, what's a centimeter? And then you have to explain to the robot, look, okay, if you don't know what a centimeter is, here, try do something that you understand. For example, in this case, the EV3 uses rotations rather than centimeters to understand its measurements. So you would tell it, move the motor in 3 full rotations. That's something the robot understands, right? And this phase of trying to fix your code and change it so that it works properly is called debugging. And so after you do debugging, you want to test your robot again, and always test, okay? And afterwards, if everything goes right, sometimes it does, sometimes it doesn't, but if it all goes right, it's a happy ending, the robot's working like we want it to. So, now this is the sort of...
Before we go into the hands-on experience, it's only 2-hour session.
Yeah.
And it's our introductory section as well.
Oh yeah, so as Shepard was just saying, because it's only the introductory session, I can't go through every sensor of a robot, teach you everything in one go. That's why we're trying to start this 8 weeks robotics course, which we'll be doing next term. So during the school term, we might have everyone here just for like 2-hour sessions every single week. We're sending out a flyer to your parents, they'll get more details then. We'll go through every part of the robot, we'll teach you everything from beginning to end about the EV3s. For now, we're just going to be going through a simple movement, and it's preferably for year 5 and 6 students, but what I want to emphasize on is if you have basic computer coding knowledge, you're chill, you're good, don't worry about it, that's all we need. Just any basic knowledge, even if it's Scratch, is good enough to understand how to code an EV3, okay? I can go through more of this later, but we're sending out flyers to everyone, so you can read through that later in your own time. Did all that. So, now we're going to create groups. All right?
Before we make group, we take a group photo while we setting up. We give them a bit of hands-on experience to see. Being a parent, you need to look at how your child is interested to do it, because we love kids who enjoy doing it rather than just doing a ticking box because parents said. With them, like I already seen a leader here, he needs to be groomed. And Shayyan, can you go back there? This is a very important thing.
Yep.
Did you go to second? Yeah, this one, yeah, go there, next. As you see the club members, they will pay only 10% of the fee as compared to the others. So if your kids join the club, then they only pay 10%, but as long as they've been in that club for 6 months. But that's a sign that all these kids only pay a fraction of the cost of the others, what they learn. So that's a very important. We are a non-profit organization called Young Innovators Australia, and we help kids to become STEM star and a leader in the school. So whatever we do, we support their learning. So before we do that, we take a quick group photo. Shami, you are ready for it?
Everyone stays in their seats, right?
No, we just make a group photo,
okay,
and
so
then we start learning in the. So it's almost what time is now?
11:45.
Yeah, so we will have a good 1 hour where they can play with this brick, and we will show you the more as well.
So everyone want to come to the front there?
Yeah, parents can go in the back. Normally people take photo in the end, we take in the middle. Meanwhile, our team quickly put the robot on each table. Please, and you can help to make a row. You can help make a row.
I know it's tempting, but don't touch the robot, please.
I know, I was just
Go and group photo. Can you, Shami, turn the light on for your thing? And you can come forward a bit because the projector is.
Oh yes, sorry. Don't touch it.
Yeah.
Turn it off.
Yeah, turn it off. That's okay.
all the little ones at the front.
Yeah.
They can be seen.